Good morning. We're going to look at imaginary numbers. The first topic is going to be imaginary numbers as powers. Remember that a power is an exponent. So, when we talk about the definition, we're going to talk about BI. B is going to be a coefficient. Is going to be a unit. Numbers. Called a unique number. I. Characteristics of an I. We know for sure that I is equivalent to negative 1 square root. Or you can also say that I squared is equivalent to negative 1. Of an imaginary number, well, we can give you several examples, would be 5i, or the square root of negative 5, even, let's say negative 9i, they can also be negative, and the square root of another negative number, let's say 100. Of I would be typical square root, so square root of 6, whole numbers like negative, or integers like negative 4, whole numbers like 10, even like, or negative square roots, let's say the square root of negative 6. So all of these are non-examples of an imaginary number. About powers. Let's go ahead and continue with powers. Our base is going to be I, and then you have the power, or the exponent. So let's say we had to the 0 exponent. I to the 0 exponent is going to be equivalent to 1, because any number variable to the 0 exponent is always equal to 1. When I have I to the first, we can rewrite it as I, and then it's equivalent to the square root of negative 1. I to the second is equivalent to negative 1. I to the third is actually negative I, and then I to the fourth. Let's go ahead and expand the exponent. So when you multiply variables, you add the exponents. So if we break this down, this would be I to the second times I to the second. I to the second is negative 1, so it's negative 1 times negative 1 equals 1. When we look at I to the fifth, we're going to expand it again the way we did I to the fourth. So let's use I to the fourth times I, just times I to the first. So I to the fourth is equivalent to 1. I to the first power is equivalent to the square root of negative 1. So if I say 1 times the square root of negative 1, my solution is again the square root of negative 1. I would like y'all to notice a pattern. So these right here are the solutions. To the sixth, I can say I to the sixth is 2I to the third. So I to the third times I to the third. So that's going to be negative I times negative I. And that's going to be I squared. So I squared is going to be negative 1. 7th to the 3rd and I to the 4th. I to the 3rd times I to the 4th, excuse me, is going to be negative I times 1. So my answer again is negative I. 8th is going to be I to the 4th times I to the 4th. So 1 times 1 equals 1. Oops, 1. What is the shortcut? The shortcut means that there is a cycle of 4. So a cycle of 4 when we are talking about the exponents. So a cycle of 4 within the exponents. So let's just say I had I to the 12th. Do is take my exponent by 4 to 12 3 times. So we look at this number right here and we have called this a remainder. So at this as our new exponent or new power. So say I had I to the 0 power. What would that be equal to? If we look back at our original note, our little side note, I to the 0 equals 1. So I to the 0 power would equal 1. So let's go ahead and use the shortcut. You're going to divide the power by 4, and then the remainder will be the new power. I is the base. We have 11 as the power, so it's I to the 11. I is the base. So you're going to say 11 divided by 4. You're going to get 2 with the remainder of 3. And I'm going to get I to the 3rd. If I look at our chart, I to the 3rd is going to be equivalent to negative I. Number 2, I can show with long division. So if I said 26, I'm going to say 26 divided by 4. 4 goes into 26 6 times, so I'm going to subtract 24. My remainder is going to be 2, so I'm going to have I squared. I squared, if I look at my chart, is equivalent to negative 1. I to the 10th, so 10 divided by 4. I get 2 with the remainder of 2. I squared is equivalent to negative 1. Again, we can do this with long division. 101 divided by 4. We get 25. 101 minus 100 is going to give me the remainder of 1. So now I have I to the first power, which is equivalent to the square root of negative 1. And we're done.